47. Alright. This is a problem that's just like all the other ones. I see two vectors that are at an angle, and I see two vectors that are either straight up and down or straight left and right. So I really can't do all this until I get the components of every single vector. So I'm going to draw the whole thing. I have the first vector that points up like this. The next one points straight up. I can leave it how it is. The next one points... Then I have one that points kind of down at an angle. I'm going to have to deal with that. So the two vectors I'm worried about right now are going to be this vector, which I'll make red. It has a length of 20 and an angle of 30 degrees. Then I have this vector up here, green. It has a length of 20 meters and an angle of 45 degrees. So we'll deal with the red vector first. It has an x component that's adjacent to the angle, which is going to be hypotenuse cosine 30. Then it has the y component, which is across the triangle. So that's going to be sine. That's going to be the hypotenuse sine 30. Sine 30 is a half, so this vertical component is equal to 10. Cosine of 30 is like 0.8 something, so I'm going to plug that in my calculator. 20 cosine 30. I get 17.3. I'm going to do the same thing for this vector that's up here in green. They're both 45. It's a 45-degree triangle, so it doesn't really matter. So I'll do one of the sides. I do 20 cosine 45, and I get 14.1. The other side up there, other side up here, 14.1. Okay. So now what I'm going to do is I'm going to worry about just all the x components. So I'm going to look at all my vectors. My first vector that I have has an x component of 17.3. This vector has no x component, so it's kind of like plus 0. This vector has a negative x component because it's pointing left, which is going to be negative 40. And then this vector, this green one, has an x component that's pointing the other direction. This one up here is pointing to the right. That's a positive number, 14.1. So overall, I'm going to do all this math. I have 17.3 plus 0 minus 40 plus 14.1. And I get an x component of negative 8.6. If I look at the diagram, that makes sense because my finishing point over here is slightly to the left of my starting point, which is over here. So my x direction to the left should be negative. And I'm going to do the same thing for the y. This bottom vector has a positive y component of 10. This big vector has a huge y component. It's actually all y component of 30. This vector up here has no y component at all, so that's plus 0. And then this green vector down here has a negative y component of 14.1. So again, I'm going to do all the math. 10 plus 30 is 40, minus 14.1. I get a y component of 25.9. That makes sense because I end up above where I started, which is a positive y direction. To find the overall magnitude of this resultant, which is basically what it asks me for. It asks me for the vector that goes from the start to the finish. It sticks out like this. I can do Pythagorean's theorem because this x component would point 8.6 that way because it's negative. This y component would point 25.9 upwards. If I make the resultant out of that, it would look like this, which looks a lot like that, even though it's a sketch. So I'll do Pythagorean's theorem, 8.6 squared plus 25.9 squared. Hit the square root button, and I get the magnitude of my answer should be 27.3 meters. And I'm done.